How are we gonna make that new element? It's due by Wednesday.
Right.
Probably using nuclear chemistry. Fusion, right?
Yeah, of course.
Yeah, duh.
Mm-hmm.
Do you know anything about nuclear fusion?
Of course
Or
I do.
nuclear chemistry?
Dude, I have my bachelor's degree in scientific science. I think I know this stuff.
I bet you $50 you don't.
Really no.
Yes, because that sounds like a fake degree.
It's not. Didn't see you there. Welcome to Nuclear Chemistry 101. I'm your host, Carson Vincent.
And I'm your second host, Ian Rogers.
And today we're going to be teaching you the basics of nuclear chemistry. Radiation, or more accurately, ionizing radiation, which is a radiation that is strong enough to rip electrons off of atoms. Now this is shown by three particles, or exerted it by three particles: alpha particles, beta particles, and gamma particles. Gamma being the strongest, beta being the second strongest, and alpha being the weakest. Now they're all very dangerous, and these particles that are ionizing radiation come from everywhere. Every year you receive around 2,000 microsieverts of background radiation. Now this radiation comes from, the rock I'm standing on, the ground my cameraman's standing on, the trees, my house, this tractor, everywhere radiation comes from. And this radiation can come from very surprising things that you would never think radiation would come from. For example, this banana releases radiation. This banana contains potassium-40, which is naturally radioactive, and when decays, it releases beta particles, which is ionizing radiation. And ionizing radiation is measured in sieverts and microsieverts. And when consuming one banana, you receive around 0.1 microsieverts.
Wow! How many microsieverts are in one sievert?
1 million microsieverts per sievert.
Wow! 1 million microsieverts.
There's also 100 rem in a million microsieverts, or 1 sievert. And a rem is how much ionizing radiation it takes to do the same amount of damage to human tissue that Röntgen high voltage X-rays does to human tissue. Thank you for watching Chemistry 101.
Here's a message from our sponsors.
Having problems losing your household items? If you've answered yes to this one question, then consider using Radioactive Tracer. Radioactive Tracer ensures you will be able to find any item it is in contact with. You're wondering how this miracle product works. Well, simply, you're pouring radioactive material onto whatever item you're using. And trust me, this is FDA approved, right? No? This is definitely FDA approved. Troubles finding your house? Pour some radioactive tracer on it. Finding your whiteboard? Radioactive tracer.
Carson, where's the whiteboard for the chemistry project? What is this? Carson, I'm sorry. I'm sorry. Carson.
We do not condone the consumption and or civilian use of a radioactive tracer.
Now back to your regularly scheduled programming. Talking about nuclear fission and nuclear fusion. Bored. Nuclear fission, very common example, is a neutron combining with uranium-235, making the very unstable atom of uranium-236, which is split off into krypton-89, 3 extra neutrons, and barium-144. A common example of nuclear fission is deuterium with tritinium, which combines into a compound, which then splits off into 1 neutron and a helium atom. Thank you.
Nuclear radiation is one of the most dangerous forms of radiation there is in all of nuclear chemistry. And nuclear radiation also goes hand in hand with radioactivity. And nuclear radiation are the particles that are released from the nucleus of an atom during radioactive decay, such as neutrons, electrons, and photons. And radioactivity is the process of which an unstable nucleus emits one or more particles or energy in the form of electromagnetic radiation. And this goes hand in hand with nuclear chemistry, like in nuclear power plants and nuclear energy as a whole. And what would happen if you were to walk into a nuclear power plant with no protection on and be affected by this radiation? And that sums it up. This may be a video game, but in real life, if you were exposed to around 2 sieverts, you would die shortly after. Nuclear chemistry has a lot to do with weaponry, and that also brings up a lot of different things. For example, half-life, critical mass, and nuclear chain reactions. For example, this fat man here fires 12 miniature nuclear missiles at once, which then ensues into a nuclear chain reaction, which is a continuous series of nuclear fission reactions. And half-life is the time required for half of a sample of a radioactive substance to disintegrate by radioactive decay or by natural process. And critical mass is the minimum mass of fissionable material that can sustain a chain reaction, and here we're going to see a demonstration. It is very effective.
That's all the time we have today, folks.
Thank you for watching Chemistry 101. I'm Ian Rogers.
And I'm Carson Vincent, signing off. Looks like I'm getting my $50 after all.